Welcome back. In this video, we will learn how to hook a native function, this string compare function with frida. Therefore, let's directly dive into this. So here we are back at the Ubuntu VM and I've got most of the stuff still open. For example, this one over here. This is the function we want to hook. Let's see, this string compare function. All right, to hook this, we need to get the address and then we can simply use our interceptor.attach. This one, by the way, that's not the address. This is the offset in this image over here. So we cannot simply use this value in our interceptor.attach. We have to enumerate it, but that's absolutely no big deal. So therefore, let's pull out our code editor and let's see how we can do this. So we are creating a new file. And this one is JavaScript. Okay, so the first thing we need to do is we need to get the address of the string compare function. Then we need to hook into this one with our interceptor.attach to this address, and then we have our callbacks, and then we need to print out these parameters. All right, and let's do this over here. So we put this on the left and this one on the right. We start over here, getting the address of the string compare function. So getting the address is within the module enumerate exports or imports. Therefore, we have to identify if this one is an export or an import. Within Ghidra, we have already seen that it's being an import, but we can also think about this. This is a function that has been defined in the libc. And this function is being included out of this libc into our code. So therefore we know this one is an import. Let's also pull out frida and put this on the right, because then it's way easier to play around with this one. We hook into this process. Let's see if it's still running, this application. Yes, okay, it's still running. So we hook into this process. It's com app hacking and then c func frida. No, okay, I have to look it up. Within the Android manifest XML, we've got this package name. C func frida. Did I miswrite? Okay, that's a little bit... This is interesting. Let's see. This application is still up. Maybe let's try to restart it with frida. Yes, okay. I'm not sure, it seems to be some bug. So simply just restart this application or close it and start it with frida. All right. So now let's see. Module.enumerate imports. This is a function that requires the library we want to enumerate, and we can get this within the libs directory. Here we have it, lib native-libso. By the way, if you're looking into the main activity, the lib in front is not mentioned over here. So here we only got native-lib. And therefore, I guess the best way is simply to check this lib directory over here and take the whole library name out of this one. Alrighty? Okay, so lib native-libso. And let's see if this one works. Perfect. Now we can see we've got all these functions: free, memset, memcopy, malloc, and so on. Here we have our string compare, but we do not want to do it all the time in this way, manually searching for this value. Therefore, we're taking our approach, iterating over this array and finding this one. We can also see this function has been imported out of the libc.so. So exactly what we have thought about. Okay, so let's see. This works, therefore we copy it. Over here, we are creating a new array. Import a function array. And here we have this one. And then we need to iterate over this array. So I'll make this a little bit larger. This is import function array. And for each, then we've got our anonymous function. And within this function, we've got our elements. Okay, and this is now a single element which has an address, module, name, and type. This means if element.name and then includes, yes. So includes, where do we have it? A string compare, I guess it was string compare. And then print it out. And console log element.name and console log element.address. Okay, let's see if this works. Yes, we've got string compare at this address. Nice. So now we can create our new address variable. And we can assign this address over here. Okay, that's definitely not a good, not a good name for this one. Address of a string compare. Maybe let's do it this way. And this one is equals element.address. All right, now we're having the address. And then we can use our interceptor.attach. So interceptor, oops, capital I, dot attach. And then we've got our address of string compare. And then we've got our callbacks, and we are double clicking into this, curly brackets, enter. And then we've got our onEnter callback, which has our arguments, and this one is important right now. Args, and let's see, and 0 is our value, and args1. And this is the value of the flag. Okay, so here we have these onEnter callback. This means we want to print out maybe both. Then we know what we have entered and what's being compared against. I need to add the space over here. Okay, now. Okay, to print out this value, we have to learn some new things. But first, maybe let's do it a simple way. Maybe let's just say param1 is equals, oops, args0, and param2 is equals args1. Maybe let's see if we are at least getting something in here. And then we've got this onLeave function, which is the return value. And this is now very interesting, because if you're having a look into this one, so if you're using the man page, string compare, here we have it, we can see string compare is returning an integer value. Can we find out based on what? Yes, okay, this is not that easy to understand. Let's see. Yes, to be honest, I do not get anything out of this one. I have to look it up somewhere else. Okay, so I like to use the reference from c++.com. Let's see if it's a little bit more easier in there. Okay, let's scroll down a little bit. Yeah, parameters return, nice. So this looks a little bit more understandable. There we go. I mean, is it that hard to provide this easy explanation to this one? If the return value of string compare is set to 0, then both strings are being equal, which means we might also just change the return value of string compare to influence our whole result. The application might think that the result has been correct and performs all the other stuff in there. And so this might be also a solution that works. It depends on the use case. Regarding to our use case where we have to get this key out of this application, it's not a possibility, but maybe for other ones. Alrighty? Okay, so now we know hooking the return value is an option, but we would like to observe those parameters. Okay, so let's get this back. And this means over here we can simply just print out the return value. And this one is the return value. And this is being printed out here. Okay, and let's see if this one works. So yes, regarding to this one, we are not printing them out really right now. I guess we are just getting the addresses, but let's see. I paste it in, and that's not a good approach. So we should restart this application and then also resume it. And now we are pasting it in. So here we have it. Now let's get back the smartphone screen. I hit check in 3, 2, 1. All right. What happens over here? The thing that happens is we've got a lot of string compare functions in our method over here. So we are now hooking every string compare function in this application. I mean, it seems to work and it looks absolutely fantastic, but I guess this is not something we want to have. Nevertheless, let's first figure out how we can print out those parameters, and then we will find some solution to only focus on our input over here. Alrighty? Okay, so back to our script. In this one over here, I guess this return value, we can use our approach to int 32. Let's see. Not this one. And here we have it. So we need to exit out of this. Whoops. Then we need to relaunch this application and resume, and then we can use it. So let's see. I'm hitting click in or check in 3, 2, 1. Alrighty, here we can see we've got now integer values, and yeah, we have also seen that they might be greater, less, or 0. It depends on if the string is equals or not. Here we can see this, for example, those has been two identical strings regarding to those references. So therefore, let's see how we can print out these strings behind those addresses. Unfortunately, I guess our Java typecasting approach doesn't work over here. Nevertheless, let's try this real quick. So we need our string class reference and java.use, and then java lang string, and then we need to typecast it. So instance is equals java.cast, and then let's see. I'm not sure about this one anymore, therefore we have a look into the documentation. So within JavaScript API, and then we are searching for cast. Yes, okay, we have to use java.cast. The first argument is our pointer, and this one is the class which we want to typecast it. If we go back into this one, this means this one arg0, that's our pointer. And by the way, this time it is arg0. Why? Because we are not in an NDK function anymore. Therefore, our first parameter is not an environment pointer regarding to the Java NDK. This is now really an argument that's being provided to string compare. This one over here. This is our S1. And yeah, our argument 1 is our S2. Alrighty? So we are not within the NDK world anymore. We are in the plain C++ world right now. So therefore, all arguments are exactly like we have them in this function definition over here. Okay, let's close this and let's see. Args1, S0, sorry. And then this is our string class reference. So let's see if we can do it this way. This has to be changed. This one bracket. Okay. So let's exit out. Resume. We are entering this, opening this application, 3, 2, 1. Okay, it crashes. So we can see, yes, chain I detection error, JObject, things like this. We cannot use a typecast from our Java string reference to this reference over here. This is now a plain C string, and therefore we cannot typecast it in this way. Now's the question, how can we access this value then? And the answer for this one can unfortunately this time not be found in the official documentation. I don't know why, but it's not a big deal. I will show you how we can do this, and I mean then we have everything set up. You only need to watch these videos if you want to know how to print out NDK parameters, plain C parameters, or Java parameters. Alrighty? Okay, so let's go back into our code. This one over here. So this one is not working. That's bad. Now's the question, how is it working? And we have in Frida another nice object, which is the memory object. So we can use memory, and then we've got this method. Let's see. Let's restart this application. memory, read, and then we've got a lot of things. Read ANSI string, that's not pointer. Read UTF-8 string. All right, this is the method we want to use. And also here we have to provide a pointer, an address to this function, and this one is now our args0. Okay, let's see if this one works. I paste it in. I hit check in 3, 2, 1. And here we can see, yes, it seems to work. We've got this string over here, parameter 1. We've got this one over here, Android OS message, and things like this. So it doesn't look like that it did work, but it seems to work. Yes, I guess it works in this way. All right. So this is how we can print out a string regarding to a plain C function in frida. And let's also do this for the other part. And this one over here, so we copy this. And we're using this one over here. Oh, sorry, it's not this one. All right. Let's see if it still works. And then we can also compare them and see those results if it's really working. We are restarting this application. Oh, I need to provide this no pause attribute. Okay, hook in 3, 2, 1. And let's see. This one was one string, this is the other. They are not equal. And let's find some strings that has been equal. There we have it. Yes, Android OS handler, Android OS handler. Those strings has been equal, therefore we're having this return value 0. Nice. And this means in there needs to be our flag and also the other part that's being compared against. How can we find this right now? I mean, we could save this into an external file and then browse through this, but this is not ideal. The easier approach is the following. If we have this over here, we can write an if statement once again. For example, we can say if this one over here, maybe let's write this into a variable. Let's name this user input. Okay, this is our user input. And now we're searching through all the string compare functions that has an argument with our user input. And this means this is the string compare function that's being used over here. Alrighty? Okay, so if our user input includes, then let's see, flag. Then we want to print out those two parameters. All right, this should work. The thing we are doing right now is the following. Maybe let's draw this real quick. Okay, within our interceptor attach, and this one over here, we are now hooking all these string compare functions. And string compare, parameter 1, and parameter 2. And we get a lot of output if we are using this one over here. So this is a lot of output. We have seen this in the previous example. Therefore, we want to limit it. And we are limiting it in the following way. We are fetching our args0, which is our user input, this one over here. And we are now telling frida, only print out these string compare parameters. I mean, we are still hooking them, but we are only printing them out if this parameter over here contains this word flag, which is this one. If this is the case, then we print it out, which means we are not having these manys right now. We are only having these two, which compare our flag with the value. I mean, if you're having multiple strings that contains flag, then we need to choose a different payload over here. Maybe 1, 2, 3, 5, 4, 6, 8, 6, 7, 9, 1. If you're providing this one over here as a user input, we can then search within the args0 for this user input, and we can, by doing this, we can limit it to only print this one out, this string comparison function. Alrighty? Okay, I mean, we are still hooking them, and this might be a little bit laggy, but we are only printing this one out. Let's try this out. Okay, so we clean the screen. And now let's see. So we close this one, we restart it. Okay. Now I paste the script in and we hit check in 3, 2, 1. All right, we can see flag seems to be contained a lot way more often than expected. No, sorry, this is the return value. Okay, my fault. We are printing still out all these return values and we can see, okay, I have to close this one. It's out of control right now. Let's close this. Okay, good. You can see hooking an libc function might be a little bit messy. All right. I didn't thought about this one. We are still printing out the return value. So this is also, okay, never mind. Just keep it in this way. So we are just ignoring the return value right now. Let's try this once again. Okay, we paste it in and check in 3, 2, 1. There we have it. Nice. We only got 1. Yes, we only got 1. And we can see parameter 1 is flag. That's our user input. And here we can see parameter 2. This is this frida hooks. Okay, insane frida hooks. This means this is our flag that's being compared with our value over here. Perfectly nice. If we change this one, and let's see, to only flag, we can check. Now we are only providing just flag. Okay, perfect. So this means even if we are hooking all these string compare functions, which are a lot, we can limit the output to the ones we are interested in. This one over here. We can define this or we can manipulate this in a way by using a unique identifier and checking this identifier in our argument. I mean, flag is also being included in this one over here. And let me bring this one up again. Here we can see it's also included in parameter 2, but this one is not being checked. Only the one we are providing in parameter 1, which is also included in the source code over here. I mean, to be 100% sure, we can choose a more unique one. And for example, 1, 2, 3, 4, 5, 6, and then a little typo, 980. Let's also do this over here. 1, 2, 3, 4, 5, 6, 7, 980. Okay, and let's relaunch this application. We resume. Here we have it. And now let's paste it in. And this one. Okay. If we are, or let's verify, if we are using flag, then we can see no output. But if we are using 1, 2, 3, 4, 5, 6, 7, 980, then we can see we have our output over here. All right, this is an amazing trick, which is absolutely useful. Okay, if we go back into this one, maybe let's also see how we can hook this return value over here. It might be interesting to see what's the return value of this function. And if we enable this one over here, then we are hooking once again all return values, which is definitely something we do not want to have. We get a lot of output. And to get only the return value of this one, of this string compare function, we have to use or introduce a new variable, because these functions are independent and therefore we cannot provide one parameter into the other one. But I mean, we can define this globally. So let's see. We are creating here a new one. Is our function, and this one is set to false, a Boolean value. All right. If we are within our function, we are setting this one to true. And if this one is set to true, then we are printing out the return value. Okay, and afterwards we need to set it to false once again, because otherwise we would have all these return values be printed out after this function. Okay, so maybe let's comment this real quick. Introducing a new state to get the, or let's say to only print out the return value of our string compare. And here verifying that this is our string compare, which we are interested in. And here setting it back to false. Otherwise, all return values afterwards would be printed out. Alrighty, this is what this new variable does. Let's see if this works. So we close this one, we restart it, we resume, and then we're taking the script. Maybe I make this a little bit larger. Yes, we can use all of this. Okay, and we paste it in. And yes, this should work. So let's see, we're hooking right now for this one. If we click check, okay, nothing appears, which is good. But if we are doing 1, 2, 3, 4, 5, 6, 7, 9, 8, 0, and hitting check once again in 3, 2, 1, there we have it. And we can also see the return value, it's not identical. Nice, isn't it? Let's verify if this one is really working. So let's also provide this one over here. Then we have to make this adjustment once again. Yes, okay. So we have to restart this application. Resume. I mean, you can also apply this no pause. I don't know why I'm not using it. So it's a little bit annoying, but yeah. So you feel free to use it. Okay, so we are applying this one, and let's see. Now we have the original flag. And this one should now return a return value of 0. And let's see. 3, 2, 1. Nice. So we can see this is definitely the return value, yeah, regarding to our function over here. And we are really accurate with our hook right now. So if we go back, we are now just printing out the string compare over here, this one, and none other. I mean, regarding to the hook, we are definitely hooking all the other string compares, but we are not printing them out. Alrighty? Okay, so this one over here, this is freaking amazing, and this trick is super neat. It will come super handy if you're reverse engineering native libraries and want to hook certain functions. For example, C library functions. Okay, maybe one last thing regarding to this one over here, this approach. I have seen in a comment from the Frida developer that read UTF-8 string might sometimes not work. So there's also an additional function that tries to read and string. This is unfortunately really complex within Frida. So Frida doesn't know at this point what type of string it has, and these types are different. Therefore, we have to try it out if some of them works. In this case, read UTF-8 string works perfectly fine. But I also want to mention that we've got other functions. For example, this one. Maybe let's check this out in Frida, because I cannot remember it anymore correctly. So let's do this over here. Read, I guess, yeah, it's read C string. Okay. This is also a function that tries to read a string out of an address. And yeah, if this one, this UTF-8 approach doesn't work, then we can try this one over here. Maybe let's see if it would work. So, or you know what? Let's keep them in here. And now let's provide them over here. Okay, and here we have to insert args0. That's not args0. And here we have to insert args1. And we need to make sure that we are also fetching or adjusting this one. Let's see if this one works. I'm also not sure about this, but this can come handy. And so let's see. We are restarting this application. We resume it. We provide our script, and we have to provide the correct flag. Okay. And let's see. 3, 2, 1. Yes, it works. Perfect. So in case if one approach doesn't work, then simply just try the other one. So within the cheat sheet, I will also provide some additional ones. We cannot talk about all of them, and it's also not clear when we have to use what, because it really depends on the library, and this is something we cannot reverse engineer or figure out. Just simply trial and error for this one. Alrighty? Okay. If you encounter some errors, have a look in the cheat sheet, And if you still encounter errors, please write me a message. I have also promised you that we've got several approaches, and one of them is also, this is freaking amazing. Within Ghidra, we've got this function over here at this address. This is of course not the real address, but we can make a hook which is really precise on this one. So we can tell Frida to only hook this single function over here. And it's amazing, because let's assume we have not that easy access to our input parameters, but we want to figure out what is happening in there. So we could hook a native function, but then we will get a lot of output, so a ton of output. Therefore, only making one hook exactly at this point, this would be absolutely nice, right? Let's figure this out. But this time we are not doing this on the real smartphone. So we are not doing this over here. We are using the virtual machine. I will prepare a whole bonus section regarding to debugging Android devices and also apps on the virtual machine. But regarding to Android devices, we have to consider a lot of things, and this would make this video unnecessarily long. Within the virtual machine, it's way easier. And therefore, we are doing this approach over there. But don't worry, within the bonus section, you will get all these information that are necessary to also perform a precise hook like this one over here on your real device. Alrighty? Okay, for now let's quit this over here and let's boot up our virtual machine. Okay, if we're using a virtual machine, let's see if this one is still running. Yes, we are still connected to this one, and we are only having one ADB device. So if you've got still multiple devices listed, the easiest way is to simply unplug your real device and then using ADB kill -server and reconnecting to your virtual machine. Yes, and then we should have access to this one. Alright, perfect. We can already see we've got an x86 prompt, which means if we want to hook a library within the x86 version, we have to use it also in Ghidra. So we need to load this into Ghidra because all these addresses and extraction will change. This one here is the ARM architecture, and this is completely different from the x86. We had a little section about this, why a smartphone is using an ARM architecture and why your PC is using an x86 version. Alright, so this means what we need to do is we need to close this project. I guess close tool. Alright, and then we've got it over here, and this is our project. So we can stay in our project and we can include this library once again, but this time for the x86 version. So let's do this. We are opening the code browser, and then within File, Import File, we are now selecting not this one, we are selecting x86. In case if you're using the x86 64-bit version, then of course you need to use the x86 64. The addresses in there might also change, but the approach is the same. So you're good to go also using this one over here. I will do it for the 32-bit version. So we select this file to be imported. And now we can see this already exists. Therefore, within the program name, we have to make an adjustment. And I simply named this libnative x86. We can see it has been automatically being detected by Ghidra. And all we need to do is simply loading this. Okay, and then we've got a quick scan, fetching all this information. And now, once again, this libnative x86 has not been analyzed. Would you like to analyze it right now? I keep saying yes. And this time we do not have this ARM aggressive instruction finder. And this time we're only using this decompiled parameter ID. Okay, this x86 does not have modes like ARM or thumb, and therefore we're also not having this ARM aggressive instruction finder in here. We can also see some libraries has not been found, but that's absolutely no big deal. These are also just external libraries, and we are interested in this function which is used in this lib. So we can simply ignore this. Okay, we can see it's being analyzed also on the bottom right. Now we have to wait until this one has been finished. Okay, it has been finished. And let's get back into our symbol tree, and we're looking for hide and seek once again. I mean, the symbols are the same regarding to the name, but now we can see the output is a little bit different. Yes. We've got some more stuff in here, and we can also see this one, this typecasting over here, it's a little bit more confusing. Nevertheless, let's get out the graphic tablet and let's do also this quick analysis over here. Alrighty, let's do this. Okay, so here we have our graphic tablet, and let's scroll upwards. Okay, so here at the first parameter, we forgot once again our environment pointer. This one over here, this is our this object. And here in parameter 3, we're having our chase string. So this one, this is our object, or this is our, let's say, user input. Okay, regarding to those parameters, it's exactly the same. And let's rename this. So we can do this by clicking on this and hitting the L letter. This one. This is our environment pointer. Sorry, environment pointer. And this one over here, this is our this object. And this one is our user input. Okay, now let's track this user input. Okay, user input is being assigned to local 64. So this is something we also need to rename. User input. Oops. And this time it seems to be a local var. Let's see, our user input is also being used in local 40, this one over here, and here we can see once again get string UTF-chars, our environment pointer. This one is an address, we do not care about this one, and here we're having our user input, which means this will be afterwards our user input. So this is also our user input. We've got a lot of user input references in here. Okay, and then once again within the string compare we can see here we're having our user input. Nice. And this one is a local variable, and we can see this one has been not defined. I mean, this one over here, we are not getting printed out this nice text, so it's not showing. And this one is not showing our flag right now. So local underscore 4c, this is our flag, but this time we are not having that easy access to it. Therefore, we want to hook this function, this string compare function. Maybe let's clear this. So we want to hook this function. And once again, we want to observe this parameter, and we also want to observe this parameter. This is our flag. Okay. Therefore, we're taking a look into this one. This is the address. But this is not the device address. If we are hovering over this one, we get a lot of useful information. So I hover to this address. Yes. So let me clear the screen maybe. Okay, so here we are having an image-based offset, this one over here. And this means the following. Our library, our libnative-libso, this will be loaded into Ghidra at an fixed offset, which means a value will be added to this one. Let's say the value is 0x1, this value, for example. It doesn't have to be this value, and it doesn't really matter. Ghidra is loading this library at this fixed address, and then we are now having this offset. So at plus 8d6c, this is an hex value. Plus this offset, we can now find this instruction, this string compare function. We only got some additional things. Let's see. We've got a memory block offset, but to be honest, we can ignore this one. This is not really relevant. And then we've got a function offset, and this can come also super handy. Our function is named hide and seek. So within our library, we've got this function, hide and seek, and so on. And now we're having an offset from this function to this point. Maybe let's say this is the point where the string compare is right now. And this is the offset over here, plus 0xcc. Okay? So this is the offset from the function to the string compare in here. I guess we will later go up to this one, and then we will see this. All right. And then we've got this one. I mean, it's exactly the same over here. This means from the starting point of this library, libnative-libso plus this value. And this is the value which will be used later on. So we are using this offset to identify where this function is being located on our virtual machine. All right? Okay, so this was a lot input right now, and we are pretty deep into reverse engineering this native library right now. Maybe let's try to summarize this real quick. What is important? The important part is that we identify where our user input will be compared. This is the function we need to hook. In this case, it's string compare over here. This time we do not want to hook all string compares, we only want to hook this string compare function. Therefore, we need to get the address of this one. But this over here, this is not the real address because the smartphone is loading these libraries at different points. It might also change every time we are launching an application. Maybe let's talk about this one really quick. This application is loading a lot of libraries. For example, this one over here, our lib native-lib so. There will be also another one, for example, the libc so, and there will be tons of other libraries that's being loaded. All of them will be now assigned to certain memory addresses. For example, 78BB and so on. And this one will be at 0x7FF and so on. And this means based on the memory layout of our smartphone, we are getting different addresses. And for example, this one over here. And therefore, what Ghidra is doing is the following. And Ghidra is loading this library into its tool. And Ghidra is providing a base address. For example, 0x10.00.00.00. And from this point on, everything will be aligned. And it will be all the time the same based on this. This is the base address. So every time we are providing the same base address, we have our functions at the same point. For example, this one over here. This is our function hide and seek. All right? Okay. So this is the difference why this address in this frida function, which is 0x10, and I'm not sure anymore, let's say 6c, is different from the real address in this device. So now we can say, okay, we are fetching one time the real address in our device, this one over here, and then we can apply all these patches on this address. Yes, this would normally work, but not on modern smartphones anymore, because every time we are relaunching an application, so every time this one will be restarted, these addresses change. So afterwards, this might be 0x720010. The reason for this change is a security feature. And this security feature is named ASLR, Address Space Layout Randomization. So let's assume we identify and buffer overflow within our application. And for example, in this library at a certain point, let's say over here. So here we are having a buffer overflow. What an attacker does is the following. The attacker jumps to a certain function, for example, the system function within our libc, and then it's executing a command in there. By having an address space layout randomization, the attacker can overwrite this address at this point, but the attacker does not know where the system libc is being located. There are some countermeasures regarding to this one from the perspective of an attacker, but let's make this not too complex. So the attacker can overwrite this pointer at this address, and the attacker can make the decision where we want to move on in the program. But if we are assigning every time a new address to the base address, then this layout over here will change. So this one over here, the offset is still the same, but this one, this is for example not 10 anymore. This one is now 720, or maybe it's located now at 710, or maybe at a complete different one, 8020, things like this. This means the address which will be hard-coded here, in this one, this cannot be reliably used to jump to a certain function within the libc binary. Okay, this is now really deep into exploitation, which is also not this topic. I just want to point out that, that we cannot rely on those cheater addresses, and that we are also getting every time a new address we are restarting this application. So we can also not rely on those fixed values. Okay, this is the reason behind this. It's a countermeasure, it's named ASLR, and it's good to have in our smartphone, to be honest. Okay, so now let's get back to our main topic, which is about hooking this function, this string compare function. Okay, being back over here, we now know why we cannot simply use this address over here. This will change, and it will change every time we are launching this application. But what does not change is the offset, this one. This offset doesn't change. The lib library, this one, this does change, but not the offset. So therefore, it's absolutely clear what we need to do. I mean, not right now, but if we have done this once, then it would be clear. We need to get the address of this library, this one, this address. And we can do this with frida, which is absolutely amazing. So we can tell frida to fetch this address of this library. Then we need to add this offset to this library. This offset, which means we end up at this address. By having this address, we can then use our interceptor dot attach on this address, and then we can also provide our callbacks. So sorry, the bracket does not close in there. We have to provide our callbacks. Okay, so I guess it's not the cleanest writing, but I guess we know what we have here. Maybe let's do this. Callbacks. Way better, I guess. Okay. Nevertheless, we will do this afterwards. So this is our plan. And by having this plan, we are only hooking this address over here. And this address is this single string compare. So this means we are having access to those parameters. Where are they? Here. This one and also this one. So we can print them out afterwards, and we can make a really precise hook in our native library, which is freaking awesome, right? Absolutely. Let's pull all of this together in one single script. Let's do this. Okay, first let's create a new script. We change to JavaScript. And we will summarize real quick the steps we need to take. The first one is getting the base address of this library. Getting the base address of this native lib, it's libnative-lib so library. Then we are getting the offset to our string compare function. Then we are adding both together, which ends up in the address we want to hook. And then all we need to do is simply printing out the parameters. All right, this is our attack plan. So let's see, the offset. This is something we can fetch from Chidra. By marking this address and keeping the mouse over this one, we can see the offset is 8D6C. The H at the end simply means that's a hex value. So 8D6C. And let's see, offset 8D6C. Maybe let's put this on the right and verify this. Yes, okay, this is our offset and this is a hex value. Perfect. Now we need to get this base address of this native library. And frida, of course, has an amazing function for this one. But first we need to start the frida server on our virtual machine. So here within data local temp, here we have this one, frida server. By the way, I have updated frida. I guess it doesn't matter, but in case if we are having some new features or running into trouble within the most up-to-date version, I would like to have it in my course. Alrighty? Okay, in case if you encounter some troubles regarding to the old version or this one over here, please write me a message, we will figure this out. So the Frida server is running right now. Let's get back our screen. Do we have it already installed? Yes, and this is our cfunc Frida. And if you click check, the flag is wrong. All right, this is working perfectly. So now we can attach with Frida to this one. Frida-u, com, app hacking, cfunc Frida. Yes, I encountered this now quite often. I'm not sure what's the reason behind this, but what works is if we are restarting this application with the -f option, then our hook will work. So resume. Yes, so we can see this one works. I'm not sure what's the reason behind this. All right, maybe let's put this on the left and this one on the right. So within the module, we've got another nice function, which is get base address. This one over here. And then we simply need to provide the library where we want to have this base address. In our case, libnative-libso. This is our library and we want to fetch this base address. And here we have it. This is the base address. Maybe let's try something. If we are restarting this application, let's see if this one changes. Once again. Yes, so we can see here we're having a different one. This means we cannot simply rely on a single one. We need to fetch this at runtime. Okay, so this one over here is now our new base address. Let's put this on the right and write this down. This is the command to get this address. Okay, and we are creating a new variable to store this. Address of our string compare function. No. This is the address, or let's call it okay, and let's put the mouse on the right. And then let's assign this to a new variable. The variable is base address. Okay, so this function over here has also a very amazing feature. I mean, the author might have also thought about this to not always calculate it manually. The offset regarding to this base address. So we're talking now about this one. This libnative-libso plus 8d6c. So our offset over here. What we need to do is we need to fetch this value and we have to add this value on top of it. Because that's the difference from our libnative-lib from the beginning. Whoops, that's not in straight line, but I guess it works out to this one over here. Alrighty, this is this offset right now. And this also doesn't change. Okay, we do not need to do it manually. Frida has this amazing feature. Let's make this a little bit larger. We can use add, and then we can simply provide our offset to this one. So we are using this one, and then let's make this large again. We are adding this value on top of it. And let's see. And there we go. Now we can see this value has been added on top. And this means this one right now, this is our address of this string compare function over here. This one. Okay? So we can summarize this together and add the offset to string compare function, maybe to the. Let's make this a little bit larger that you can read the whole comment. Okay. Base address, or let's maybe rename this. Address to hook is our final address we need to attach. So this one is now the address that's being applied to our interceptor.attach. This one, it's also included over here. Maybe let's also rename this. Is the offset to our string compare function. Okay. Now we've got everything together. That's also done. And the only thing we need to do is we need to use our interceptor attach on this one. So interceptor.attach. And then we've got our address to hook in this one. And then we've got our callbacks. Double click, curly bracket, few times enter, on enter callback, anonymous function. Here we're having our arguments. And this one is now the single string compare function within our libnative-libso library. And that performs the check of the flag. All right, so let's print this out. Parameter 1 is, and now we are using memory.read UTF. I need to have this frida because I cannot memorize this one. So memory.read UTF-8 string. Okay. And this one over here. And we're using this on args 0. One bracket is missing, and there we have it. And this can be deleted. Okay, this is our parameter 1. And now we're doing this for parameter 2. And this time, there's a comma missing. We are also having this on leave. A function, this is now our red value. And this time we can directly print out this return value because we are only hooking one single function. Therefore, this won't be flooded like the previous example where we have hooked every single string compare function. Alrighty? Okay, so this one here is our return value. And this one we know the return value. Return value is 0 if strings are equal. So this means our return value is an integer. Yes, this looks perfect. Let's see if this one works. I mean, these are just a few lines to hook a very complex function within a native library. Amazing, right? Let's see if this works. So let's copy this. Okay, we are restarting this application. I resume manually. I hope you have attached this -- no pause, that it's not that dump like I'm doing it right now. Okay, here we have our application. I'm super excited if this one is working. Okay, no errors. Let's see. I'm hitting check in 3, 2, 1. Okay, we are getting an error, but we are also having this one, flag insane frida hooks. All right, the first parameter seems to work, but the second one doesn't. And now we also have to mention we are on a different architecture. This means these parameters are now changed. Okay, this is now a lot of stuff, I know, and this is really unfortunate. And we can unfortunately not talk about all of this right now. If you have some questions, of course, feel free to write me a message. But let me try to summarize this real quick. I'm really sorry that it's that complex right now, but maybe you can figure out what's going on, and this would be absolutely amazing. So within the last example, our first parameter, this was the string we have inserted into this application. This one over here is now in different architecture, and therefore the calling convention is different. These parameters are being swapped. In the first parameter, we are not having our string right now. We are having the solution, this one over here. And to be honest, I do not know why we cannot decode the second one, this one. This is our string that's being provided to this function over here. So maybe there's some issue regarding to the typecasting. All right? Okay, so this is what's happening over here. I mean, it's amazing. We can see we are only hooking one single function, this one over here, and it seems to work. I mean, it works. We've got the proof over here. So what we can try is the following. Instead of using this read UTF-8, we can try to use this read C string. And let's see. Okay. Now we are not having frida anymore. I get it back because I would like to use the IntelliJ of frida. So read C string, this one. Okay, read C string. Maybe C string is able to print this out. Let's see. I mean, okay, we can leave this open. We are applying now our patch. Has the application been resumed? We are not sure about this one. Maybe let's change this. Okay, we are hitting check in 3, 2, 1. All right, we are not getting an error, but we can see this one. I mean, it's now being typecasted to a C string, and this seems to be also no C string, but at least we are not getting an error. I will do some research on this, what's happening in there, and then I will provide an update on how to hook this parameter. Right now, I have also no clue why this is the case. Regarding to this post from the main developer, we can see can't decode byte at a certain position. So this is regarding to playing around with read C string or read UTF-8 string. So dealing with strings when the encoding is not known right now, it's really rough, and unfortunately there's not an easy way. We have to use a lot of options and simply try them out if they work. All right? Okay. Alright, as promised, here's the update regarding to the parameter issue. It might be an issue within an older version of frida, which is nowadays more up to date, or it might be an issue with frida in general and the x86 architecture. Right now I have recapped everything, and regarding to the parameter, it's working on an ARM device. So let's have a look. This is the native lib, so this is now the, let's check this. The lib for the ARM architecture 64-bit, because I'm using now a real device in Pixel 2 and this one is an ARM architecture 64-bit. Okay, we load this into Ghidra and check the string compare, because this offset is now different. We can see this offset right now is at, let's see, F0B8. Okay, so let's put this into our script. Okay, so here we can see this is our old script, but I have already updated it. Let's have a look into this one. All right, we can see this one was the old offset, and all I did is just updating it to the new offset. So let's also mark this here in the comment. Okay, and now I didn't have changed anything. So we still got read UTF-8 string, argument 1 and 2, and also the return value. Within the return value, we still have a problem. So I'm not sure why it's not being printed out. I will debug this in the frida script, and I will make a whole chapter regarding to debugging Android code, frida code, C code, and things like this. For now, we have to wait until I figured it out. Okay, but back to this one. This was our task. So let's see. This is now our script. Let's run frida. Okay, and then let's get the smartphone here. Okay, and now let's run this. So let's restart this application. All right, we can resume it. And now we are copy pasting this code. So this code into the console. All right, it looks a little bit messy, but we are good to go. And now all I do is simply hit check. And there we go. We can see this is our provided input. We can see it's a crystal clear string. And also here's the second parameter. This is our flag. Perfect. The thing that's missing right now is this return value. And I have to debug it. It might be in case of leaving the string compare function based on an asynchronous call that it's not being printed out right now. But yeah, I will make a whole chapter regarding to this one. If you want to have both the parameters and return value, then I guess simply choose the other approach regarding to the string compare, where we do not hook a dedicated address, where we hook all of them. Then we will make sure that we're hitting the parameters and also the return values. Alrighty? Okay. So this is all for this video right now. Maybe let's do a little bit of a recap. Within Ghidra, we have identified where our parameter is being passed into this function. This one over here. So we have tracked it down from this one to this one, and from here into this function. Then we know, okay, this is the function we want to hook. Here we have seen we've got an address, but this address is not the real address. This address will be calculated based on the loading point of this one, plus this offset. This one will unfortunately change every time we are relaunching this application, so we cannot use a hard-coded value. But this is absolutely no problem for us in Frida right now, because Frida has this amazing feature get base address out of this library, and this even more amazing feature to automatically add a certain value onto this one. So by having this line, we are getting the offset within our application to this point over here, to this address in our smartphone app. By having this one, the rest is pretty easy. We can apply our interceptor.attach on this address, and then we are using these arguments to print them out. This one, I'm not sure why this one fails right now, but I will provide an update to this video over here. And also within the cheat sheet, I will provide a lot of options that you can try out to read out a certain string. Over here, we've got the return value. And I guess we didn't check the return value, so let's go back. Okay. It seems like the return value does not get printed out over here, maybe because of this error. This would be a little bit strange. Okay, so this one is also unfortunate, and for now I have no explanation why this is the case. Also on this, I will provide an update what's the issue and how to solve this. Regarding to our hooking approach, we have seen we can also hook really precise one function in our complete code. And we have also seen we can hook all of these functions in our code, which will be a little bit messy. But we also know how to deal with this one by providing a unique identifier over here. For example, this one, 1, 2, 3, 4, 5, 6, 7, 9, 8, 0. And then checking for this unique identifier and only printing out this function that has this set as an argument. Here we have seen this works perfectly fine. And this is also my recommendation of choice to go for this one over here. Alrighty? Alright, this is all for this video right now. In the next one, we will have a look into a real world capture the flag. This will be our red belt challenge. And this one, it's really not that easy. So if you can solve this, this would be freaking awesome. And then you absolutely deserve your red belt. You would be an absolutely Frida ninja in hooking all these Java methods, creating new instances, observing instances, or playing around with the NDK, or even playing C functions like we're having it over here. So this is what we have learned in this chapter, and this is a lot, and it's freaking awesome that you are still there and made it through the end of this one. Therefore, I'm really looking forward to see you in the next section where we're having a dip into the challenge. See you there.